Alright, this is lesson 3. This is a little bit of a curveball. It's kind of a lesson you need to get through, and we're just putting it at the beginning of the year. Students will convert common units of measure using conversion factors. Okay, conversion factors are when we take one form of a weight or of an item and put it into a different form. Kind of like, you know how you drink soda? When you get a huge bottle of soda, how many liters is that? 2 liters, right? And then couldn't you buy smaller versions of soda? Right? So a can of soda is so many milliliters. What's that? Okay, something like that, right? I don't know if that's necessarily accurate, but you got the idea, right? Okay? Good example. So we're going to learn how to convert things, because sometimes you're like, how many cans of soda will fit into a 2-liter bottle of Coke? Does that make sense? So we're going to use conversion factors. 2 of the main ones we're going to use today, and this should be pretty easy for you, are time and distance. Those are the only 2 we're going to look at. We're not going to do really complex problems. So here are the steps. If you're in the video, you're going to identify what unit you start with and what unit you end up with. Use the appropriate conversion factor to convert the units. Multiply the original units with the conversion factor. And then you simplify. Okay? So these are word problems, very light word problems. And we're going to just use the directions. So just watch numbers 1 and 2. Actually, I need you to write these down, because these are the ones. There's actually hundreds of conversion factors, and you need to know how to deal with them in real life and in math. But also in real life, I know that you have your phones. You could do this on the internet really quickly, but you need to know the concept before you understand that. Okay. So these are the conversion factors. Pause the video if you're on here. I'm going to move on. Numbers 1 and 2, just watch right now. Okay, you could go back later and copy it. So we need to move forward. I'm sorry? So San Dimas students are in class for 320 minutes a day. At least how many hours are the students in class? So that's actually how long you're in class every day, from periods 1 through 6, or 1 through 7. Okay, so if students are in class for 20 minutes a day, how many hours are the students in class? So the first thing we want to do is start off with the first unit we're working with. So just watch right now, 320 minutes, okay? And I'm going to use MIN to represent minutes. And I can make anything a fraction by putting it over 1, okay? So at least how many hours are the students in there? We need to use conversion factors. So if I go back to my previous page on time, I know there are 60 minutes in an hour, right? Okay, so I want to go from minutes to hours. So I need to figure out how to go from that. So I'm going to multiply by another fraction, and I want to do the opposite of, or I want to put the minutes on the opposite side of my fraction. So I want to put minutes down here. And I'm going to use my conversion factor. I know for 60 minutes, I want to end off in hours, right? So I know a conversion factor will be, for every 60 minutes there is 1 hour, okay? And then I multiply the fractions out. We got 320 times 1 hour is going to be 320. And then 1 times 60 is 60, okay? I could cancel out minutes, like so, and all I'm left with is hours at the top. Now I have a division problem, 320 divided by 60. Remember how we were doing some division for homework? You do a side problem. Does 60 go into 320? Nope. Or does it go into 32? No, it goes into 320. And it goes in 5 times. So we got 5 times 60 is 300. Subtract and I get 20 as my remainder. That means there are 20 minutes. But the question's asking, at least how many hours are students in the class? Well, students are at least 5 hours, right? So we're going to write students as a complete sentence, because it's a word problem. Students are in class at least 5 hours. Okay, and that's it. That's how you do number 1. Any questions on number 1? Okay, again, what did I just do? First thing I did is I read the problem completely. I figured out what was the original number or the unit I wanted to go from. I wanted to go from minutes to hours because the problem gave me the problem in minutes, and then I want to end off in hours, right? Does that make sense? So I just needed to go from minutes to hours, so I started with 320 minutes, made it a fraction, and I knew there was a conversion factor for minutes to hours. There are 60 minutes for every 1 hour. Then I started to multiply and simplify. Minutes canceled out, hours was left, so I multiplied 320 times 1 is 320. 1 times 60 is 60. Then I know this is a division problem, so I did a side problem. I figured out 5 hours and 20 minutes is how long you're here for every day. Long time, right? So students are in class at least 5 hours, okay? Does that make sense? Let's do another one. Sandeema's students are in class for 320 minutes a day. How many seconds are they in class? Okay, this one's a little different, okay? I'm going to still start off with 320 minutes and make it a fraction. But this time I want to know how many seconds there are, right? So on my conversion factors, I notice there are 60 seconds to 1 minute, right? You see that? So I'm going to go back here and I'm going to multiply this with a new fraction. Since I started with minutes right here, I'm going to put minutes down here. And I want to end off with seconds. My conversion factor is that there are 60 seconds for every 1 minute. Do y'all see that? So now we're going to multiply across. We know minutes cancel out. 320 times 60, I'm going to have to do a side problem. So then our answer is going to be 19,200 seconds. So once we're done, we're going to write students are in class 19,200 seconds. That's a lot of seconds a day. And that's it. Alright? Any questions on numbers 1 or 2? Okay. You will use this in this method in science for sure. Yes?
You want us to do it that way and then shortcuts, like you just can't just do 320 times 60? Or would you prefer
I want you to follow the form because when you work in another class like science, you will use this form of conversion factors, and then it gets kind of complicated. I know you could go quickly and just be like, oh, I just need to divide. In this lesson, we're also going to do 2 conversion factors at once, which gets a little more complicated when we have to divide twice. Okay, so that's why. And I'd prefer this so that we know what we're going after. But that is the shortcut. Yeah, you could do that. So I want you to understand the concept first. That's why we're doing this lesson. Okay? Questions? All right, so let's have ones tell the twos about number 1, explain how I did the problem, and then switch. Twos will tell the ones about number 2. Ready, set, go. Number 3. Okay, the length of an average car is 177 inches. At least how many feet is the car? Okay? So look back in your notes. Think what the conversion factor is from inches to feet and work it. I'll give you a minute and then write your answer down. Number 3, we start off with the original problem, 177 inches, and I need to go to feet, right? So I need to make this a fraction, and I'm multiplying with a new fraction. This one is we need to find a conversion factor. Look up here. Here's a trick. Look up here. Eyes up here. I'm showing you right now. No iPads right now. Stop touching them. So the inches, since we start with inches, we have to put inches down here. It has to be the opposite right there. And I want to end off in feet. So I know that there are 12 inches in 1 foot. Do y'all see that? So now inches could cancel out here and here. And we multiply. 177 times 1 is 177 feet. divided by 1 times 12, which is 12. Then you do a side problem. 177 divided by 12. How many times does 12 go into 177? Once. 1 times 12 is 12. Subtract, you get 5. How many times does 12 go into 51? 4. Multiply, you get 48. And remainder of 3. So the question is, at least how many feet is it? How many feet is it at least?
14.
14 feet. So the car
Isn't it 57?
Oh, 57. Oh, I'm sorry. Did I make a mistake back there? Oh, I pulled down on one. I don't know why I did that. Thank you. Okay, so bring down to 7. Okay, how many times does 12 go into 57? 4. Okay, still irrelevant, so remainder of 9. The 9 we don't need to worry about, so, but we go back to our sentence. The car is at least, how many feet? 14 feet. Okay, does that make sense? Okay, try it again. Number 4. A football player runs the ball 26 yards. How many feet did the football player run the ball? I know there's a shortcut, but this is an easier problem. I want you to do the form that I showed you. I'll give you a minute to do that. Ready, set, go. Last one. More people got it. Yeah.
Because you just want things to seem like they have more. There's more variables.
Well, look at this one. This one is 26 yards. Okay, make this a fraction. We're gonna multiply it by a fraction. What goes in the denominator automatically?
1.
No. Oh, and the first one, but on the second fraction, what goes in the denominator right here automatically? Yards. Okay. What are we trying to end off with? Feet, right? So how many feet in a yard, or how many yards in a feet? 3 feet in 1 yard. You see that? And then if you were to work this out, you got 26 times 3. What's 26 times 3? 78 feet. Okay. What's the difference between problems 3 and 4? What's the only difference?
It's multiplying, the other one's dividing.
Good. The other one's multiplying, the other one's dividing. Okay. So is dividing that much harder than multiplying? It shouldn't be that much harder. Maybe it's a little more difficult for some, but it's really not that much harder. So, problem is set up the same way, and that's it, okay? We ran out of time today because we started class late and we had all this other stuff we had to do. So, that'll conclude the lesson for today. If you need help, go on the video. You can rewind.